Normal distributions are used to model continuous data. However, there are many situations where discrete data can also be modeled as normal distributions. Here's an example. A company produces boxes of chocolate. The number of chocolates in a box is assumed to be normally distributed with a mean of 48 chocolates and a standard deviation of 4.3. Quality control will reject any box with fewer than 44 pieces. Boxes with 55 or more pieces will result in excess costs to the company. So first we need to figure out what our random variable is. In this case, we're going to let x represent the number of chocolates in a box. This is a discrete variable because you can only have one chocolate or two or three or four or five. You're not going to have part pieces of chocolate. So this is a discrete variable. So if you're asked what is the probability that a box selected at random contains exactly 50 chocolates, we're going to be tempted to write it like this: the probability that x equals 50. We can't do that because we're trying to use a normal distribution to model discrete data. So we have to change this into a range of values. The best way to do that is to just go 0.5 chocolates on either side. So we're going to change it so that we're looking for the probability that x is between 49.5 and 50.5. And now we need to convert that into z-scores. We know that the mean is 48 chocolates and the standard deviation is 4.3. Recall that to calculate the z-score, you take the value minus the mean and divide by the standard deviation. So when I change my x value of 49.5 to a z-score, it becomes a z-score of 0.35, and my x value of 50.5 has a z-score of 0.58. So I'm really looking for the probability that the value of z is between 0.35 and 0.58. And if you'll recall from a previous lesson, that's the same as the probability that z is less than 0.58 minus the probability that z is less than 0.35. At this point, you'll use your z-score table to look those up. So the probability that z is less than 0.58 is 0.7190, and the probability that z is less than 0.35 is 0.6368. So when you do the math, you get 0.082. So to answer the question, there is an 8.2% probability that the box will have 50 chocolates. So we can ask another question: what percent of the production will be rejected by quality control as containing too few pieces? Well, a box is rejected by quality control if it has fewer than 44 pieces. And it's accepted if it has 44 pieces or more. But since we're using a normal distribution to model this discrete data, we're not looking to plug in the number 44. We have to change that to a range, remember? So we're going to say that 44 exists between 43.5 and 44.5. So when we want to know what's the probability that we're going to have less than 44 chocolates, we're really looking for less than 43.5 in our normal distribution model. So that's what I'm going to find: the probability that x is less than 43.5. I have to change that to a z-score, so I'm looking for the probability that z is less than negative 1.05. So when I look up my z value on my z-score table, I get a value of 0.147. So about 14.7% of the production will be rejected as having too few pieces. Here's another question for the same situation. Each filling machine produces 130,000 boxes per shift. So how many of these will be in the acceptable range? So remember, the acceptable range for these boxes of chocolate is between 44 and 54 pieces of chocolate, including 44 and 54. So when we change this to our range of numbers for our normal distribution model, the low end of this scale would be 43.5, and the high end of this scale would be 54.5. So we're looking for the probability that x is between 43.5 and 54.5. And I'll change those into a z-score by doing my z-score calculation. So I'm looking for the probability that z is less than 1.5 minus the probability that z is less than negative 1.5. If I look up those numbers on my z-score table, I find that I'm dealing with 0.9345 minus 0.1469, which is 0.788. So 78.8% of the boxes will be accepted. Now in the question, we're told that 130,000 boxes are produced. So that means 102,440 boxes are going to be accepted. So if you were running this company, you'd see that clearly there's too many rejects with this current process of packaging. And then you would want to think about adjusting this process to get a smaller standard deviation and get a more consistent number of pieces in each box.